it's a beautiful day, let's call into work and we'll go out and play, sweet darling. 'Cause I've got nothing but time on my hands, I just wanna spend a little time with my man, sweet darling. You grab the rocks and I'll get the bait. We'll do a little fishing, let's make it a day with the blue skies above and the sun on our skin. Oh, sweet darling, let's go fishing.
Okay, so I'm here with Daniele Tonina from University of Idaho. And how were you first introduced to the idea of ecohydraulics?
Hi, Gaga. Thank you for asking me this interesting question. So it happened actually stumble. I started my career looking at groundwater and then moving to the river morphology. And at that time I started to be exposed to the interaction and feedback that happened between organism and sediment transport and soil morphology. So little by little, moving from the civil engineering experience that I had and training, then I moved into ecohydraulics.
Mm-hmm. Yeah. What's an example of an ecohydraulics research article that's influenced your research?
One that really impacted me was actually looking at the impact that salmoni had in the past on how much sediment transport they could move during the formation of red, and the way that we were able to clean the sediment from fine sediment. So the interaction between the population of salmonids to create the egg pocket and the morphology of streams, it was quite connected. And so understanding this feedback, I think, is extremely important.
What's an example of a research project you're working on right now?
Yeah. So right now we have been working on looking at the impact of river morphology on the amount of quality and quality of water that can be exchanged into the sediment through the high breakdown. And what we were looking at was how the hydraulics impact the biogeochemical reactions. And what we notice is that the velocity that is into the pores actually is a driver of how reactive the sediments are, and so how they can clean and self-purify that one. And that was something that was overlooked in the past. So now we know that knowing information of surface hydraulics also help us to determine how fast certain streams can actually clean its own water.
That's pretty cool. Yeah.
Thanks.
So looking into the future, what's an ecohydraulics topic that you think future generations will be better positioned and really will need to work on?
That's a very important question, actually. I think that one of the major parts is really to understand not just how the physical system impacts the biology, but also the vice versa, so the full feedback that happens. I think there is a loop. So the physical template create a template, but over which then a biology will grow and will affect the template. And I think be able to understand this feedback will help us to improve our understanding of the environment, but also be able to engineer the environment in order to improve or enhance or remediate what we have done in the past.
Right. And is there anything else you'd like to add about ecohydraulics?
I think ecohydraulics is, in a certain way, the future of both ecology and hydraulics or hydrology or morphology, because we start to realize that is the feedback that happens at different levels that really create a river, and the morphology of the river is not just the sediment and the water, but is also the vegetation around it, how the vegetation interact, the organisms that lives there and make possible a certain vegetation to happen. So it's all this interaction that I think is the future of us as scientists to learn, and also for the future student.
Yeah. All right. Well, thank you very much.
Thank you for having me here.